In this video, we will learn about solution of nonlinear equation. So a little bit of introduction. All this while, you already learned on how to solve a linear equation. For example, question A, if we have 2x minus 1 equal to x plus 3, you only have to rearrange back the equation to obtain value of x. Same goes to quadratic equation. If you have, let's say, x squared plus 2x minus 3 equal to 0, in order to find values of x, you only have to factorize it out and then you will obtain the value of x. Okay, so next one. If we have x cubed minus 8, same as before, we can rearrange back the equation and then apply the power rule, so we will obtain the value of x from this one. But how about, let's say we have equation of x cubed minus exponent to the power of x equal to 0, or x minus sine x equal to 1. So there's no algebraic method exists in order to find value of x in this case, and that's why we will classify this as solution for nonlinear equation, and that's what we learn in this topic. As before, when this occurs, we will turn to numerical method to approximate the solution of our nonlinear equation. So it is impossible to find the exact solution, but then we can find the approximate solution for that equation. So before we find the approximate solution for that equation, we need to prove first that the solution is actually exists. So in order to do this, we have two different methods, which are graphical method and algebraic method. Okay, so for graphical method, for sure, you have to sketch a graph first. So in this case, we have two different type of graph or graphical method. So first case, let's say you have a function that you can directly sketch the graph. In this case, they just name it y equal to fx. So based on these notes, you can straight away sketch the graph of fx. Okay, how do we determine the existence of solution or roots? In this case is basically based on x-intercept, where our x-intercept means that the solution exists. So our roots exist there. So in this case, here let's say x-intercept between 1 up to 1.5, we approximate that the root exists at 1.3. So that's the approximation value. Okay, so moving on, next one. This is the second case. If we have a function that we cannot directly sketch the graph. So what do we do here? We have to split the function into two different functions and then sketch the graph separately. So where the root exists or the solution exists, it's basically the intersection between the graph. Here, intersection between the graph and not on x-intercept. To be clear, let's do a example, specific example. Okay, now let's say we have equation of ln x minus sin x equal to 0. Okay, so we can rewrite back this equation into two separate functions because for sure ln x minus sin x, we don't know how to sketch it. Okay, I rearrange back. On our left side, we have ln x, and then on our right side, we will have sin x. Now we have to sketch it separately. So for ln x first, I'm very sure everyone don't have problem to sketch that part. Ln x, okay, I highlight it in a yellow color. And then for sin x, I try to highlight it with a blue color. Alright, so root exists when it comes to the intersection between these two graphs. So here it's intersect in the middle. That's how we approximate the root. Okay. So that's for graphical method. Now, for algebraic method, so basically we have to find the change of sign between the function when we substitute x value of the function. We will elaborate this more through an example. Okay. So the first example, find the approximate value of the equation ln x plus x minus 2 equal to 0 by using both graphical method and algebraic method. So in this example, we will use both approach or both method. So we start with the graphical method first. Okay, so for example, now we have ln x plus x minus 2 equal to 0, and I'm very sure not all of you will know how to sketch this graph. So what do we do here? We will split it into two different functions. So for ln x, I leave it on our left side, and then for right side, I will rearrange to be 2 minus x. Now we will have two separate functions. So first one, we have ln x, I name it as fx. Second one is 2 minus x, that's basically linear function, I name it as gx. Okay, now we may start sketching the graph. So for graph, don't forget you must begin with your axis, x-axis and y-axis. So first function for ln x, okay, so we have a ln x here. Alright, so don't forget to label your intercept. So here it should be 1. So that's for ln x. Next one, for the second function, I'll use different colors. So we have 2 minus x. Okay. So it's just a negative linear graph. 2 minus x. Okay. So y-intercept. And then y-intercept should be 2. And then x-intercept also should be 2. Okay. So based on this graph, root axis or the approximate value of our solution will be the intersection between these functions. So I'll put a circle there for the intersection of that graph. So here we know that the root axis in the middle between x equal to 1 and x equal to 2. So I just approximate it to be x equal to 1.5. So at this point, actually, you can approximate any values as long as it is between 1 and 2. For example, you want to approximate, let's say, x is 1.3 or 1.4. It's up to you as long as it is between 1 and 2. So that's for graphical method. Alright, now with the same example, let's try to do with algebraic method. Okay, so for algebraic method, first we have to name this function as either fx or gx, up to you. So I name it as fx. So fx in this case would be ln x plus x minus 2. That's our function. Okay, now after that, we have to substitute two different values of x to make sure we have a change of sign in this function. So let's say first value I test x equal to 1. So we will have ln 1 plus 1 minus 2. So in this case, we will obtain negative 1. So this is a negative value. Alright, next one. Consecutive value of x, I put x equal to 2. So we will have ln 2 plus 2 minus 2. So here in this case, we will obtain 0.69. And this is a positive value. So from here, we can notice that actually we have a different sign, a positive value of a positive value and negative value of fx. I put here different sign ataupun change sign. So since we have a different sign here, we can make a conclusion now. We have a different sign between f1 and f2. So root axis between x equal to 1 and x equal to 2. So our approximate value here, I'll just choose the middle value between x equal to 1 and x equal to 2. And in this case, it will be 1.5. So this is how we do for algebraic method.